In this video, we are going to see a problem under Fourier series, that too odd and even case question. So, expand f of x is equal to 1 plus 2x by pi, 1 minus 2x by pi. Here 1 plus 2x by pi in the interval minus pi less than x less than 0 and 1 minus 2x by pi such that 0 less than x less than pi. And hence deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square etc. equal to pi square by 8. In this question, the interval is minus pi to 0 and 0 to pi. The total interval is minus pi to pi. That interval is splitted as two interval minus pi to 0 and 0 to pi. So whenever the interval comes from minus pi to pi or minus L to L or minus 1 to plus 1 like that, we need to check the given function is whether even or odd function. So to check that, we need to substitute x is equal to minus x in the given f of x. So now we will take the interval minus pi less than x less than 0. In this interval, what is our f of x? F of x is equal to 1 plus 2x by pi. In this interval, we substitute x is equal to minus x. So in the left hand side, f of minus x is equal to 1 plus 2 into minus x divided by pi. Where is the interval? Interval is minus pi less than x less than 0. So now what will happen? This will become as 1 minus 2x by pi. So 1 minus 2x by pi is nothing but this is also our f of x with the interval 0 less than x less than pi. So which is equal to f of x. So now we arrived that f of minus x is equal to f of x. Therefore, given f of x is an even function. Given f of x is an even function. Therefore, when f of x is even, bn equal to 0. So we need to find only a0 and an. In our Fourier series contains a0 and cosine term only. There won't be any sine term. So now we need to find the value for a0. a0 equal to 1 by pi integral minus pi to pi f of x dx. So now f of x is an even function. So this can be written as 2 by pi integral 0 to pi f of x dx. Okay, integral 0 to pi, our given f of x is 2 by pi integral 0 to pi f of x is 1 minus 2x by pi into dx. So now we need to integrate this. We can get the answer for a0. So which is equal to 2 by pi integral 1 into dx, that is dx. So integral dx is x minus 2 by pi is a constant. Integration of x is x square by 2. What is our limit? Limit is 0 to pi. We can cancel the 2 and 2. Here 2 by pi, upper limit is pi. So pi minus pi square by pi. Our lower limit is 0, so that is 0. 0 value, so we no need to write the 0. So now you are getting pi. So that is equal to 2 by pi square minus pi square by pi. So what is the answer? a0 equal to 0. So our a0 answer is 0. Now we need to find the value for an. Formula for an is an equal to 1 by pi integral minus pi to pi f of x cos nx dx. This is the formula for an. So now we are going to find an. So to find the an equal to 1 by pi minus pi to pi f of x cos nx dx. Given f of x is an even function, cos is also an even function. Even into even, again it is an even function. So even function can be written as 2 times of integral 0 to pi f of x cos nx dx. So 2 by pi integral 0 to pi. Integral 0 to pi, the f of x is 1 minus 2x by pi into cos nx dx. Now we are going to apply Bernoulli's formula. We will take the differentiable term as u, integrable term as v. So u is equal to 1 minus 2x by pi, v equal to cos nx. Differentiation of 1 is 0 and minus 2x by pi. Minus 2 by pi is a constant. Differentiation of x is 1. So v v is cos nx. So integration of cos is sin nx by n, and v2 equal to integral sin is minus cos nx by n square. So Bernoulli's formula, integral uv dx equal to uv1 minus u dash v2 plus etc. So now we are going to apply the result. an equal to, okay, an equal to 2 by pi u 1 minus 2x by pi v1 sin nx by n minus u dash minus 2 by pi v2 minus cos nx by n square with the limit 0 to pi. Here the first term is sin with the limit 0 to pi. We know very well that with the limit 0 to pi, sin term is coming. Before apply the limit itself, we can make the term as 0 because multiples of sin pi is 0, sin 0 is also 0. So we have only the second term. Here minus into minus plus 2 by pi minus cos nx by n square with the limit 0 to pi. Now you can take the minus and 2 by pi outside. So minus 4 by pi square. Apply the upper limit is pi. So cos n pi is minus 1 power n, and lower limit is 0. So minus cos 0 value is 1. So 1 by n square. So this one can be written as 1 by n square minus 1 power n by n square. Here it is plus. So what will happen? 4 by, we can take the n square also outside. 4 by pi square n square into 1 minus 1 power n. Whenever the term coming 1 minus 1 power n, in this case we have to give the values for n. When n is equal to 1, what will happen? Minus 1 power 1. So minus into minus, this will become as plus. So that will become as 2. So 4 into 2, 8. 8 by pi square n square. So 8 by pi square n square. This is when n is 1. Suppose n is equal to 2. What will happen? Minus 1 the whole square, that is plus 1. 1 minus 1, that will become as 0. 0 into anything 0. So when n is 2, this will happen. So when you are giving the odd numbers, you can get the answer is 8 by pi square n square. When you are giving the even number for n, you can get the answer is 0. So an answer is splitted into two cases. An equal to 0 when n is even. An equal to 8 by pi square n square when n is odd. So the required Fourier series is, this is the Fourier series expansion, a0 by 2 summation over n equal to 1 to infinity an cos nx. In this one, a0 answer is 0. So 0 sigma n equal to 135, because an takes the value only in the case of n is odd. So n equal to 135 8 by pi square n square cos nx. Or up to this the Fourier series expansion is over. In some authors used to write like this, that is 8 by pi square we can take outside, sigma over 1 by 2n minus 1 the whole square cos 2n minus 1 into x. This is also right because in the odd number representation is 2n minus 1. So if you are able to understand, you can write this, or otherwise the problem is completed up to this only. So now the first part of the problem is over. After this we are going to see the deduction. For the deduction part, we need to deduce that 1 by 1 square, 1 by 3 square, etc. equal to pi square by 8. This is what the second part of the question. So we have the Fourier series f of x is equal to 8 by pi square sigma 135 up to infinity 1 by n square. So in this one only we need to find the deduction. So at the point of x is equal to 0, at x is equal to 0, because the given interval is minus pi to plus pi. So obviously the mid value I am going to take, that is our point of continuity. So this is our point of continuity. So at this point the f of x is continuous. So at the continuous case we need to put the point directly in the f of x. So f of x is what? F of x is equal to 1 by, we have two cases, that is 1 minus 2x by pi or 1 plus 2x by pi, whatever it is, f of x is equal to 1 plus 2x by pi or 1 minus 2x by pi. In the both cases, if you are substituting x is equal to 0, anything by 0, this term will become 0. Only f of 0 equal to 1 you can get. So obviously f of 0, f of x converges to, so at x is equal to 0, f of x converges to, f of x converges to 1. Okay, so in this left hand side, f of 0 equal to 8 by pi square sigma n equal to 135 etc. up to infinity 1 by n square. So 1 by n square, here we can take that f of 0 converges to 1, which is equal to 8 by pi square sigma 1 by n square. So you take this left hand side. So pi square by 8 is equal to sigma 1 by n square. Now we will give value for n. So n equal to 1, this will become as 1 by 1 square. Then n equal to 3, 1 by 3 square. Then n equal to 5, 1 by 5 square, etc. equal to pi square by 8. This is what our second part of the question. So here we have taken x is equal to 0 is a point of continuous. So point of continuous means f of x converges to that point. So when you are substituting x is equal to 0 in the given f of x, we are getting f of 0 equal to 1. So left hand side we are substituting 1. Here we are giving the values for n. You can get the deduction answer. Thank you for watching.